Okay, so today we're going to talk about limits, and the first thing we're going to talk about is what exactly is a limit. So to start off, let's just start with a very nice and simple definition of a limit. So the limit L is the value that f of x approaches on the y-axis as x approaches a number a on the x-axis. And you can see that on this diagram, right? For each value of x, you have a corresponding value of y, f of x. And as x approaches a, you see that y also approaches this red dot over here, right? So, for example, if x was equal to a, then your y value would be equal to this value here, which is L. Now, it's important to also keep in mind that x never reaches a, okay? So x never reaches a, and f of x never reaches L, right? The idea of a limit is simply where will f of x be as x approaches a. So keep that in mind, because a lot of students tend to think that f of x has to be equal to the value L when x is equal to a. And you'll see that as we go forward, there are certain functions, specifically piecewise functions, that will show us that when x is equal to a, f of x doesn't necessarily need to be equal to this limit value L. Okay, so now that we have a general idea of what a limit is, let's talk about how to write limits mathematically. So the way that we express that a function's limit is equal to a certain value is by writing it this way. We start by writing LIM, which stands for limit. Then underneath it, we write x followed by an arrow pointing to the number that x approaches, which in this case is a. We then write the function whose limit we are taking and set the entire expression equal to the limit value. Here, the value is L. So the way we would read this is the limit as x approaches a of f of x is equal to L. So let's take, for example, suppose we have a function f of x is equal to x plus 2, right? And let's say that we know that the limit as x approaches 1 of this function f of x is equal to 3, right? And you can verify that if you substitute x equals 1 here, you get 1 plus 2, which gives you 3. So suppose we know that L is equal to 3. So the way we write the limit here is the limit as x approaches 1 of x plus 2 is equal to 3, right? So our a value, right, the a value here is 1, and our f of x is x plus 2, and our limit here is 3, right? We can do, let's say we have f of x is equal to sine of x. And let's say we already know that as x approaches pi, then f of x approaches 0, right? So we know that our limit is equal to 0. So we can write the limit as x approaches pi of sine of x is equal to 0.